Imagine this. You walk into a room and the system immediately realizes who you are. No need for passwords, keycards, just your face. Just like in a sci-fi movie. What if I told you that by the end of this video, you'll be able to code your very own facial recognition system? All you'll need is a webcam, Python, and some libraries. Well, buckle down, because that's exactly what we're going to be doing in this video. First, let's get the basics right. Face detection is the process of detecting a face within an image. However, facial recognition is able to identify and match the image to previously stored identities. This process involves two core concepts. Encoding, the first concept, is the process of converting facial features into numerical data, essentially what we call a face print. The second concept is matching. This matches the encoding to previously stored identities within the database to detect if there's a match or not. Let's begin with the setup. First, you're going to need to make sure you have Visual Studio Code on your laptop installed if you don't have it already. On Visual Studio, you're also going to need the C++ and Python packages. For this product, we'll need three essential libraries: OpenCV for handling video input, face recognition for encoding and matching faces, and NumPy for processing data. Open your code terminal on your device and enter the following command. Note that OpenCV's headless version excludes GUI components. Perfect if you're running this on a server without a display. Also, make sure your Python version is 3.7 or higher to avoid compatibility issues with these libraries. We'll need images of faces to train our system. So first, we'll start by setting up our webcam and creating a script to capture images of yourself or anyone you want to recognize, as well as making sure we have a directory for these images to go to. This will keep everything organized. This is the first code that we'll input. In this project, we'll have to rely on these following libraries. OpenCV will handle our camera feed and show the live video. OS will create folders and organize the saved images. NumPy will store face encoding in files, and face recognition will detect faces and convert them into the encodings. The OS function checks if the faces folder already exists and creates it if it doesn't. The name input lets us save our captured images with the names that correspond to the person's identity. Finally, we initialize the webcam using the video capture function. Now, let's dive into the core of our training process. We'll write a loop that continuously captures frames from the webcam. This loop will allow us to display the current frame, capture images when the user presses a key, and save the corresponding encodings. Here's how this code looks like. Let's break this down. The while through line begins an infinite loop that will continuously capture frames from the webcam until we manually stop it. Using capread, we capture a frame. This returns two values, a success flag and the current frame. If capturing fails, we print an error message and break the loop. Next, we display the frame in a window titled Training. This allows you to see the live video feed from your webcam. When you press the C key, the current frame gets saved as an image in the Faces folder with the name you provided earlier. This image presents the face we want to recognize. We convert the captured frame in an RGB format as the face recognition library requires it. The face encodings function then generates a numerical representation of the detected face. If an encoding is found, it gets saved as a .npy file for later use. If no file is detected, a message prompts you to try again. Lastly, if you press Q, the loop breaks, and we clean up by releasing the webcam and closing all OpenCV windows. In this next part, we're going to be importing our previously saved encodings, which will help us compare the new frames to our previously stored identities that we have. We'll also be creating a live video feed, which will help us recognize faces in real time. The first thing we'll do in this code is import the necessary libraries. After the libraries are importing, we'll create the load encodings function. This function goes through all the files in the faces directory, looking for files that end with encodings.mpy. This extracts the person's names from the file name, loads the encoding using numpy load, and stores both the encoding and its name in the lists. Once the function runs, it returns two lists. Known encodings, this creates a numerical representation of saved faces, and class names, which are the names of the corresponding to the saved faces. Next, we use CV2 video capture to access a default webcam. This allows us to capture video in real time. Since working with high-resolution video can be slow, we apply a scale of 0.25. This reduces the size of each frame to 25% of the original, making it easier to process without much delay. Now we're adding the final part, real-time facial detection and recognition. This part captures each frame, detects faces, and compares them to previously saved encodings to identify people in real time. For the final piece of our code, the capBreak method captures a new frame from the video feed. If it fails to grab a frame, we print an error message and exit the loop. Since the face recognition library works with the RGB images, we convert the frame from BGR, the default format used by OpenCV, into RGB. The face recognition.faceLocations function detects all the faces in the frame and returns the coordinates. The face encodings function extracts the numerical encodings for each of the detected faces. For every detected face, we use a compare faces to see if it matches any of the known encodings we loaded earlier. If there's a match, we grab the corresponding name and set it to uppercase. We draw a green rectangle around the detected face. Below it, we draw a filled rectangle and overlay the name label. The updated frame with all detections and labels is displayed using cv2.imshow. If the user presses Q, the loop ends. After the loop ends, we release the video capture and close all OpenCV windows to free up the resources. Now that our code is completed, this is a demonstration of how our real-time facial detection system will work. And there you have it, a real-time facial recognition system. But this project wasn't without its challenges. The face recognition library was a little bit tricky to set up because it had a lot of Visual Studio dependencies. The facial detection system also needed a little bit of tuning, and we sped our frames up so it was easier to use. We also added error handling in case no face was detected in the image. Though these adjustments are very minor, they help make our system a lot more reliable. Thank you for joining me in this tutorial. Real-time facial recognition systems, just like this one, have the power to transform our interactions with technology and improve security in our day-to-day lives. Imagine a world where these systems help improve our safety and our connectivity. Keep exploring, innovating, and together we can build a better world.